Good evening, my name is Benim Shadik and I'll be taking you through local search algorithms, adversarial search and adversarial machine learning. So, now we shall first talk about local search algorithms, where we have hill climbing, which continuously moves in the direction that increases value, similar to hiking up or climbing a hill. Now we have the pros, which is easy to implement, good for problems with smooth and predictable solutions, and the constraints we can have that it can get stuck in a local optimum, which means that it may not always find the best solution. An example is optimizing the order of tasks which you may have in a work day. Now, the other one, you have simulated annealing, where it adds controlled randomness to sometimes allow worse moves to help escape local optima, and it's inspired by the process of cooling method to achieve stable structure. An example, we have adjusting city lights to optimize traffic flow. And the other thing we have to talk about is genetic algorithms, which are inspired by natural selection and evolution. And these ones, genetic algorithms, work by evolving a population of solutions over time. And now the process of genetic algorithms by which they work, we start with random solutions, we evaluate them, select the best and combine them to create new solutions, and then thereafter we have random mutations are introduced to maintain diversity and explore new possibilities. Now the pros of genetic algorithms is that they can explore a very large solution space and often find high quality solutions, and the constraints are that they are computationally expensive first of all, and secondly that they require evaluation of many possible solutions, which can be a problem. An example we can have for that is designing a layout for a small apartment. Now we can talk about responsible AI and explainable AI in relation to the local search algorithms and genetic algorithms. And the responsible AI in general, it ensures that the solutions provided by these algorithms are ethical and fair. An example is that using genetic algorithms to allocate healthcare resources. And for explainable AI, it makes algorithms more transparent, allowing users to understand and trust the decision-making process. For example, in simulated annealing, users need to understand why the algorithm might temporarily choose a worse solution to eventually reach a better one. Then, we can talk about adversarial search, which is used in competitive scenarios where multiple sides have opposing goals. And in this case, each player makes an attempt to make the best move while anticipating and countering the opponent's moves. And the two scenarios you can have in this is in marketing, where companies use adversarial search to adjust their pricing, predicting how competitors might react, and sports, where teams may use adversarial search to develop strategies that take into account the possible actions of the opposing team. And now we can talk about MiniMax and MiniMax algorithms. And now in MiniMax algorithm, it is a recursive algorithm that is used to find best possible move in a two-player game or zero-sum game. Now in this case, one player tries to maximize the advantage while the other tries to minimize. For example, in a chess game, an MiniMax, it's an extension of MiniMax, but in this case, this one incorporates probability to handle games involving chance. For example, in a game of Monopoly. Now we can talk about Alpha-Beta Pruning, and it basically optimizes the MiniMax algorithm by eliminating branches of the decision tree that are unlikely to influence the outcome. And the purpose is to speed up decision making without affecting accuracy. And for example, in chess again. And then we can talk about adversarial machine learning, which studies how to make machine learning modules secure against adversarial attacks, where inputs are manipulated to trick the model. And the types of attacks, we have evasion attacks, where a trained model is fooled with slightly altered inputs, and poisoning attacks, where we are manipulating the training data so that the model learns incorrect patterns. And now the only defense that we have against this is adversarial training, which involves training the model with adversarial examples to improve its robustness against such attacks. Now, the relation to adversarial search is that both involve making decisions in adversarial environments. Now, adversarial machine learning secures models against attacks, while adversarial search focuses on finding the best moves against the opponent. Thank you. Have a great day.